2021 Canadian Open Mathematics Challenge, Part B. A bag contains two regularly shaped cubic dice which are identical in size. One die has the number 2 on every side. The other die has the numbers 2 on 3 sides and the number 4 on each side opposite to one that has number 2. You pick up a die and look at one side of it, observing the number 2. What is the probability that the opposite side of the die has the number 2 as well? Express your answer as a reduced fraction. Okay, so the first die, if we just draw a basic, has 2 on all the sides. So, it doesn't really matter which way you're looking at this. There's a 2 everywhere. So there's a 2 here, 2 here, 2 here, and you get the point, right? 2 on the side, 2 on the bottom, 2 on the back. But the second die, that has a combination of 2s and 4s. So they have 2 on 3 sides. So we'll try to put in, I guess, 3 sides. So let's see here. Put a 2 on the front, a 2 on the top, and 2 on the right. And then the other sides will have a 4. So on the bottom, on the left, and on the back, I guess. Okay, so what are they saying? They're saying that figure out the probability that if you pick up the die and look at a side and it has a 2 on it, that the opposite side also has a 2. Okay, so let's talk about this one. If you pick up the die and there's a 2, what's the probability that the opposite side will have a 2? Well, 100%, because they all have 2s. So you've got 6 ways of looking at the 2, right? Because there's 6 sides. And all of them will have a 2 on the opposite side. So let's just keep that 6 for now. How about this one? If you pick up the die and look at one side and there's a 2, how many ways is there of doing that? Well, there's 3 sides that have a 2 on it. Okay. But all of those will have 4 on the other side. So none of those will have 2 on the other side. Okay. So now let's figure out the probability. The probability is, usually a fraction. The numerator is the specific condition. The denominator is the total. The total in this case is this 6 and this 9. This 6 and this 3, which is 9. The numerator is our specific condition, which states that if you picked up the die and you looked at it and there's a 2 on the opposite side, there will also be a 2. The only ones that match that criteria are these guys. Because with this one, if you pick it up and there's a 2, the opposite side will have a 4. So none of those match our specific condition. So that's really the probability. And they want it reduced, so no problem. Reduce, it's 2 over 3. When the product, this big long thing, is expanded and simplified, was the coefficient of x to the power of 2021. We assume that the indicated patterns continue. Okay. All right, so obviously we're not going to expand the whole thing. We're just going to sort of figure out what happens. Okay, take the first term and multiply it by something in the other bracket to get x to the power 2021. And that basically would be, I think, just initially this guy and this guy. So that would give me minus 2021 x to the power of 2021. So I only care about x to the power of 2021. Anything else, I'm not interested, because I'm really just looking for the coefficient of that power of x. Okay, so how else can I get it? Okay, I get it with this multiplied by the x. So that would be plus 2020 x to the power of 2021. Okay, great. And then how else can I get, well, I can keep going. The next one, they don't write it in here, but I'll write it in here. It will be 2019, right? X to the power of 2019, I believe. Yeah. So that obviously would need to be multiplied by that. And that would therefore make that negative 2019 x to the power of 2021. And you can continue this process. Then I'll just do one more. The next one is going to be 2018 x to the power of 2018. Correct? Like what would go in there? And that would need to be multiplied by this. So that would be plus 2018 x to the power of 2021. Yeah, and then you just keep going like that. And when you keep going like that, dot, 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 you will find that eventually you will start having to pair up the very last one. So the very last one that will give you a coefficient x to the power of 2021 is, I believe, this one right here. This times that. So that's going to be minus x to the power of 2021. You see what I mean? Now I'm going the other way. I'm going from last and backwards. Then after that, it would have been this one and this one, which is plus x to the power of 2019. So that would be plus 2 x to the power of 2021. So you see what I'm saying? And then the next one, if you just keep going this with this pattern, it'd be 3 x to the power of 2021, and so on. And I think by now you kind of get an idea of what's happening. Now, if I factor out the x 2 to the power of 21 and just look at the coefficients, then you'll get a pretty good idea of what's happening. Just pair them. When you pair them, you'll see that you'll get minus 2021 plus 2020. That's the first pair. And then if you pair the next two, you get minus 2019 plus 2018. And then you just keep on going like that. And then how many are there in total? This is sort of like 1, right? So 1 to 2021. Okay, so it's not an even number. So that makes me think that it's going to pair like this, and then there's going to be 1 left over at the end. Okay, so eventually you're going to get to minus 3 plus 2, and then there's going to be a negative 1 at the very end. And this is all the coefficient in front of x to the power 2021. Okay, so each of these guys is negative 1. So negative 1 plus negative 1, a whole bunch of negative 1s, plus dot, 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 negative 1, and then the very last negative 1. And then that's all x to the power of 2021. Okay, so now there were 2021, but I do not want to count this one because that's by itself. So that means if I don't count that, there's 2022. Sorry, 2020. So 2020 from this guy to this guy. Now each of those is paired up, so that means 2020 numbers divided by 2 would give me the number of pairs. So 10 pairs. So that means there's 10 of these. So 10 times negative 1, and then don't forget that last negative 1. And there you go. That is pretty much the coefficient of x to the power of 2021. And that would be minus 10 minus 1, x to the power of 2021. And that is minus 1011. That is the coefficient of x to the power of 2021. Two right triangles, triangle AXY and triangle BXY, have a common hypotenuse XY. Sides AY and BX intersect at P. Side lengths in units are AX equals 5, AY equals 10, BY equals 2. Determine the area in square units of triangle PXY. Okay. All right, so I'm going to, instead of calling them PXY and all that stuff, let's just make some variables here. These triangles, PXY, AXP, and BPY. So PXY, I guess, is the one in the bottom, AXP, and BPY. Those are the 3 separate triangles in this diagram, and I will label them PXY I will call X, AXP I will call Y, and BPY I'll call Z. Now, let's see here. We are given that these are right angles at A and B, so that's very helpful. So we can use Pythagoras And also given a lot of units here that ax is 5, ay is 10, by is 2. So that's going to help us. So using Pythagoras, I know that 5 squared plus ay squared, which is 10 squared, is equal to xy squared. Yeah. So that means that this is 25 plus 100. So 125 is xy squared. So xy is the square root of 125, which is 5 root 5. So this xy at the bottom is 5 root 5. Okay, and then I think I can get bx, that also with Pythagoras, bx squared plus by squared, which is 2 squared, is equal to xy squared. And xy squared, well, that one is 125. We just figured that out. So bx squared plus 4. So therefore, bx would be square root of 121, which is 11. Okay, that's great. Got a nice integer there. So bx is 11. So I guess we'll just put that in here, 11, all the way from b to x. Okay, so now we can utilize these right triangles. That'll be very helpful for us. The first right triangle, which I'll say, which one do we want to talk about here? pxy plus axp. So we'll talk about x plus y. So x plus y is pxy plus axp. So that basically is axy. So triangle axy. And using just the standard 1/2 base times height, the base will be ay, which I believe is 10, and the height is ax, which is 5. So this is 25. So that means x plus y is 25, where x is this guy and y is this guy. In a very similar way, we can calculate x plus z. X plus z is really pxy plus bpy, which is essentially bxy. Triangle bxy, if you combine those. And then again, since it's a right triangle, we can just use 1/2 base times height, which would be 11 times 2, and therefore that's 11. So x plus z is 11. Okay, that's some pretty good equations. Now we have a similar triangle situation. Triangle PAX is similar to triangle BPY. So always try to prove it, or not prove it, but show you why that is. PAX, and I'll just draw it a little bit on the side here, just to kind of show you that they are similar. PAX would be this guy, right? It's something like this. And this is a right triangle, and we'll call this theta. And therefore, this angle would be 90 minus theta, this angle there. And then BPY is sort of like this, where this is 90. And because this is 90 minus theta, this will be 90 minus theta, right? Opposite angles. So that angle in there is 90 minus theta, and therefore this is theta. So they have the same angles. Because they have the same angles, that's why they're similar. So that means if we take a ratio of the sides, which is by in this guy, in this triangle, by over ax on the other triangle, which are both the 90 theta sides. The 90 theta sides are by and ax in those two triangles. That's equal to, well, we know the actual values, 2 and 5. Okay, but this is a linear relationship. What we want is a relationship for the areas. And that, the good news is, all you have to do is just square them. So you just have to square 2 over 5 to get the area relationship. And the areas we have a sort of a relationship for. let's move this up a bit. So from here, that equation, we get that by was 2/5 ax, right? That's our linear relationship. But our area relationship would be 2/5 squared, and the areas of the two triangles. So by represents the triangle BPY. So BPY we had called Z, right? So triangle BPY, that area. And this AX here, that was representing triangle AXP, or PAX, whichever way you want to write it. AXP. And then we had given them values. So that means Z is equal to 4/25 AXP, which is Y. Okay, so this is a very important relationship that we have come up with. All right, I think what do we have to do in this question? We have to find PXY. PXY. Okay, so PXY is X. Okay. Okay, that's straightforward, because then we just have to use these equations. So that means X plus Y, which is 25, and X plus Z, which is 11, we can solve this, because we know that Z is equal to 4/25 times Y. So let's substitute that into here. So we get, let's see here, or probably substitute it into there. X plus Z, which is 4/25Y, is equal to 11. And now this equation I'll call 1, and this equation I'll call 2. We can use, if we just use 1 minus 2, we can solve this pretty quickly. So 1 minus 2 would give me Y minus 4/25Y, so 21/25Y. And then 25 minus 11, which is 14. Okay, so that means Y is equal to 14 times 25 all over 21. And that looks to me like 2/3 of 25. So that's going to be 50/3. Yeah, 50/3. And then to get X, I can just substitute it back into this formula. And therefore I've got X plus 50/3 is equal to 25. So X would be 25/1 minus 50/3. So that's going to be 75 minus 50, so 25/3. And X is what I had chosen to represent triangle PXY, which is what they wanted me to figure out. The equation sine of x is equal to x over 2021 pi has exactly n solutions. We measure x in radians, find n. Okay, let's draw a diagram. And let's just make a sketch. Let's make a sketch of first y is equal to sine x, right? We all know that one. This one, y is equal to sine x. And in a very sort of, basic way, we know this one. So you guys all know this graph, and I've put these dots in to show that it just kind of keeps on going, because we're going to have to extrapolate this. Now, we know that the sine of x is always between 1 and -1. So this graph is always going to be between 1 and -1 on the y-axis. Okay, so that means we can write it sine of x is between 1 and -1. Now, we are not given the actual sine of x is equal to y. We've given it that it's equal to this. All right. So since it's equal, we also need that this guy, x over 2021 pi, is also equal to, between -1 and 1, right? Because sine of x is equal to x over 2021 according to the question. Okay. So that means that if we multiply everything through by 2021 pi, we get 2021 pi, and we get -2021 pi, like that. So x is going to be, if this is the x-axis, obviously, on this side, the maximum it'll go to is minus 2021 pi. And on this side, the maximum it'll go to is positive 2021 pi. So wherever that is. And that's the maximum. So I'm assuming it'll be somewhere, I'll just draw what I think. It'll be something like this. Since it's the maximum, we can actually put it into this formula. Sine of x is equal to x over 2021 pi. When x is 2021 pi, you'll get sine of 2021 pi is equal to, it'll be just 1. Yeah. So when x is 2021 pi, we'll get something like this. It'll be somewhere here. I'm not sure, to be honest, where it'll be, but it obviously, since it's 1, it'll be the maximum. So let's just say it's somewhere here. So where that is 2021 pi. And then that red dot represents the point 2021 pi, and with the y coordinate of 1. Okay. So now we have to figure out what happens in between. Great, you got this thing out there. Well, you can do this sort of manually for the first few and get a pattern. We know that the basic sine graph, this is pi, this is 2 pi, right? This is 3 pi, I think, and this is 4 pi, and so on. So let's see what happens. If you were to draw a line, you would eventually see that it crosses only the graph in the first quadrant, right? Because whatever value of x you put in that's positive, it's going to make the y value positive. So what that means is that if, for example, when x is 0, you're going to have 0. And then when x is pi, you're going to have some value, some fraction, very small fraction. It'll be here, but it'll be a positive. And similarly, when x is 2 pi, it will be 2 over 2021. So again, it'll be positive, and then so on. You see what I'm saying? So it will be always like that. So if we were to extrapolate this, it'll kind of go like this. So there'll be 1, 2, 3, 4, and so on. So since this graph has a period of 2 pi, meaning it repeats every 2 pi, it looks to me that it has 2 intersection points. So I'll write that down. Each period, which in this graph is 2 pi, there are 2 intersection points. Intersection points. So that means that if I extrapolate, I can figure this out. So how many times are we going here? We're going to go all the way until, we're going to go until 2022. So this final point down here, 2022 pi. And then after that, we don't need to worry because it will have crossed over, like, it'll be like that. After that point, it will never cross the graph anymore. That line will never cross the graph because we've maximized it at 1 right here. So till 2022 is what we need to worry about. So that means 2022 is the extent of the x values. Now there's a period of 2 pi. So if we do that division, we get 1, 0, 1, 1. And that's how many periods there are. And in each period, there's 2 intersection points. So we have 2 times 2, 1, 0, 1, 1, which is 2, 0, 2, 2 intersection points. Okay, great. But we didn't talk about this guy, right? That's going to be the exact same story. Exact same. So it's also going to have another 2, 0, 2, 2 intersection points. To the left, I guess, of the origin. Okay, so we got 2022 plus 2022. So we are down to 2022 plus 2022. But don't forget one very, very important thing, that we've counted the origin twice, right? We counted it in this calculation and we counted it in this calculation. So because we counted it twice, we have to subtract it once. There you go. That's the complete solution. And when you do this math, it comes to 4043.